right. So when a compound that is an ionic compound and it is soluble in water, if it's placed into water, if it's placed into solution, whoops, excuse me, if it's placed into solution, then we know what happens to the ionic compound. Right, Fred?
Yeah, I think I know what you're talking about.
Well, as we see here, calcium chloride, when it's placed into water, it becomes aqueous. What happens is the ions dissociate from each other into their constituent ions, calcium ion and the chloride ion. This compound dissociates into its constituents. All right, and notice how if I have two compounds, two units, two silver nitrates here, then I end up with two silver ions and two nitrate ions. A calcium nitrate has one calcium and two nitrates, therefore I'm going to get one calcium ion and two
Nitrate ions.
Nitrate ions. That's right. Good. Thanks. Okay. So, strong electrolytes, weak electrolytes, and non-electrolytes refer to the degree to which they dissociate when they're in water. Conductivity of solutions relates to the number or the concentration of ions in solution. So this is a solution of, or not a solution, but just water, or it could be a solution of water and sugar, because sugar, C6H12O6, is not an ionic compound, all right? So a solution of water and a compound like this, which is not an ionic compound, would be indicated like that, this thing, aqueous, being in water, right? But it would not conduct electricity. Electricity could not pass through it. A solution of copper sulfate, like this one here, CuSO4. Copper 2 sulfate dissociates when it's in solution, and the products are the copper ion. What's the charge on this copper ion? Do you know?
Didn't you call it copper 2 sulfate?
Yeah, that's right, I did. So that tells you that it's the +2?
Yeah.
Now, if I hadn't called it that, is there any way that we could have identified what the charge was there on the copper?
I guess if I knew the polyatomic ion, I have that chart there. So sulfate's a -2, so that'd be a +2.
Very good. That's another way that you could go about identifying the charge on the copper here, right? Okay, so these ions in solution result in conductivity. A strong electrolyte is one that dissociates into its ions. A non-electrolyte, a compound that when it's in solution, it's just in solution. It's not dissociated into ions, right? And weak electrolytes are, for example, an example of a weak electrolyte is something like ammonia. We'll talk a little bit about that later, or a weak acid. All right, these are compounds that, when placed into water, they partially dissociate. Okay. Now, not all compounds dissociate. Not all ionic compounds dissociate when they're placed into water. So, for example, iron 2 oxide. All right. When I put it into water, it won't dissolve. And if it's not dissolving, it's not going to dissociate into its ions. We have a set of rules here to help us identify whether these compounds will dissociate when placed into water. All right. These are called solubility rules. And you can read through them and make predictions about compounds based on these rules. All right. So why don't you take a look at these compounds here, use this list of rules. This list of rules is also provided for you on the back of your periodic table, right? So you can bring up the back of your periodic table, and I'll bring up these compounds here. Here's the list of that rules there. Why don't you see if you can identify whether or not these compounds are going to dissociate, and if they are going to dissociate, write the dissociative products. All right, write the resulting ions. Be sure to remember to use coefficients to identify the number of ions. Okay, push pause, see if you can get this done. All right, let's help them out, Fred. Here we go. Ready?
Yeah.
Okay, so what's the name of this first compound?
That's sodium and phosphate. So sodium phosphate.
Very good, sodium phosphate. And any rules about either of those ions, sodiums or phosphate in here?
Rule 1 says that something about sodiums.
That's right. Group 1, which sodium is part of group 1. I'll bring up our periodic table here so we can take a look at that as well. Here's sodium in group 1, right? Group 1 are soluble, with a few exceptions, all right? Salts containing ammonium ion are also soluble. Okay, so if this is placed into water, what are our products going to be, Fred?
Got sodium ions and phosphate ions.
That's great. That's very good to notice that we got sodium ions and phosphate ions. Do we know the charge on sodium ions?
That's +1.
All right, so +1. Phosphate ions?
3 minus.
All right, we got that from the periodic or the polyatomic ion chart maybe, or you're remembering a little bit. That's good.
I'm remembering.
Okay, good job.
Actually, I didn't remember. What I did was I just looked at saw that there was 3 sodiums, and so I knew I needed 1, or phosphate had a 3 minus charge.
Okay, that's good stuff too. So you said you saw that there were 3 sodiums and they all had a +1 charge, so you knew that the phosphate had to have a 3 charge.
Yeah.
Okay, good. So these are the resulting ions when sodium phosphate is dissociated, dissolved into solution. Okay, and we can represent that by saying 3 sodium ions and 1 phosphate ion. Okay, good. How about this next one?
There's 2 aluminums, 1 sulfate, no, 3 sulfates.
Yeah, 3 right there, right? 2 aluminums, 3 sulfates. What's the charge on aluminum ion? Do you remember?
The periodic table, do you have that?
Okay, here's aluminum down here.
Okay, is that the 3 plus one?
That is, aluminum is a 3 plus ion. So there's going to be 2 of those 3 plus ions, and how many, what's the charge on the sulfate?
Doing the crisscross rule backwards must be -2. Let me check on my polyatomic ion chart. Yeah, it's -2.
Okay, good. Yeah, there's our polyatomic ion chart. Sulfate right here, -2. Good. So 2 aluminums and 3 sulfates. Okay, how about this next one? Is it soluble?
Yeah, rule 3 says that chlorides and bromides and iodides are generally soluble. Important exceptions rules. Okay, yeah, so it should be soluble.
All right. So there are some exceptions for chlorides, bromides, and iodides, but calcium is not one of them, right?
Yeah.
Okay. So how many calcium ions?
1,
Chloride ions?
2,
What's the charge on the calcium ion?
+2.
Okay, good. +2. You could remember that because of the its location on the periodic table, right? Okay. So, last one here. Remember the name of that compound?
Do you have the polyatomic ion chart?
Polyatomic ion chart. Let me bring that up here. There we go.
Oh, calcium permanganate?
Yeah, very good. Calcium permanganate. Excellent. Is it soluble?
Let me see. Is there anything about the permanganate ion on there?
Let's see. Do we have anything about the permanganate on here? Ion on here?
MnO4, MnO4. I'm not seeing anything.
Okay. So most sulfates, most hydroxides, most sulfides and transition metals are insoluble. Carbonates, chromates are frequently insoluble. Phosphates are frequently insoluble. Fluorides are frequently insoluble. Yeah, I don't see anything about the permanganate ion. Permanganates are generally soluble, though. Okay, so we got how many calcium ions?
Just 1.
And how many permanganates?
2.
And what's the charge on the permanganate?
-1.
Very good. So we got 2 calciums. Oh, I should have asked you the charge on the calcium. It's +2.
Yeah, I knew that.
Okay, yeah, we had it right up here. All right, so looking at these compounds, which one will not produce the chloride ion when placed into solution? Any ideas here?
Oh, they all have the chloride ion. Maybe it's all produce E? I feel like there's got to be a trick here, though. Hold on just a second.
Okay, why don't you at home sit and try to think about it too?
I don't know this one.
Okay, if we look at these compounds and we try to identify what their dissociative products would be. So for sodium chloride, for example, what would the dissociated resulting ions be?
Sodium ion and a chloride ion?
Very good. One sodium and one chloride. And you have to make sure you say how many of each, right? From now on, you can't just say sodium ion and chloride ions. I say one sodium ion, one chloride ion.
Okay.
And then for this one here, what would we get?
One lithium and one chloride? Well, maybe that's one's it. Maybe that's not soluble.
Okay, so we can check with our solubility rules, right?
Oh, yeah. So, no, lithium is group 1, so it's soluble.
All right, so it's soluble. It will dissociate. How about PCl3?
Chlorides are generally soluble.
There's something else here, though. What's going on with PCl3?
I don't know. What do you mean?
Well, let me show you something here. There's something else going on with PCl3. If we look at phosphorus and chlorine, we see that phosphorus is over here. What does that tell us?
I don't know. What?
Well, it's to the right of the staircase, right?
Oh, yeah. Okay, so it's a not an ionic compound, so it won't create chloride ion.
That's right. It won't create the chloride ion or the phosphate ion because it's not an ionic compound. Okay, great. How many ions form upon the dissociation of sodium phosphate?
How many? What kind of ion?
Well, it doesn't say what kind. It just says how many ions in general.
2 ions, sodium and the phosphate.
Now remember, you have to look at how many of each there are, right? So yes, I'm going to get sodium ions, I'm going to get phosphate ions, but how many sodium ions am I going to get?
Oh, 3.
And then how many phosphate ions?
1.
Very good. So our answer here is 4. 4 total ions that I'm going to get when that dissociates.
Okay, I got it.
Let's do one more like that.
This one's easy. It's 5.
Okay. How many aluminum ions?
2 and 3 sulfates.
All right. So that's 5. Okay. And this is
Oh, just 2.
just 2 ions, right? Just 2 ions. Oh, they got us. What's the matter?
I don't know. Is it 5? No. Oh, maybe it's just 1.
No. Something else. What is it?
I don't know.
It's this.
Oh, what does it say?
Rule 8 says carbonates are frequently insoluble. Group 2 carbonates like calcium, strontium, and barium are insoluble. So calcium is a group 2, right? Calcium here is in group 2, therefore it's insoluble. Therefore, when you put it into solution, you're not going to get any ions. That's 0.
Oh, okay. I got it.
All right, good stuff.